formula for voltage drop calculation for single-phase systems is voltage drop equals current times distance times resistance divided by 1000, where voltage drop, measured in volts, is the amount of voltage lost over the distance. Current, measured in amps, is the current flowing through the wire. Distance, measured in meters, is the length of the wire. And resistance, measured in ohms per meter, is the resistance of the wire. Here are the steps to calculate voltage drop for 480 volts single phase. Firstly, determine the current. Calculate the current flowing through the wire using the following formula: current equals power divided by voltage, where power, measured in watts, is the total power consumed by the load, and voltage is the voltage of the system, which is 480 volts. Secondly, determine the distance. Measure the length of the wire run from the power source to the load in meters. Thirdly, determine the resistance. Find the resistance of the wire based on its material, size, and temperature. For 480 volts single phase, you will need to use number 4 aluminum wire. Refer to the wire resistance table or use an online calculator to determine the resistance. Fourthly, plug in the values. Substitute the values of current, distance, and resistance into the voltage drop formula. Voltage drop equals current times distance times resistance divided by 1000. Here's an example. Load power is 15 kilowatts. Wire distance is 50 meters. Wire resistance is 0.15 ohms per meter. Calculation: current equals power divided by voltage equals 15 kilowatts divided by 480 volts equals 31.25 amps. Resistance equals 50 meters times 0.15 ohms per meter equals 0.75 ohms. Voltage drop equals 31.25 amps times 50 meters times 0.75 ohms divided by 1000 equals 11.63 volts. Therefore, the voltage drop over the wire run will be approximately 11.63 volts. To elaborate on the first step, determining the current is crucial for accurate voltage drop calculations. Ensure the power is in watts when using the formula current equals power divided by voltage. If the power is given in kilowatts, convert it to watts by multiplying by 1000. For example, 15 kilowatts equals 15,000 watts. This conversion ensures consistency in units, leading to a correct current value. Neglecting this step can introduce significant errors in the subsequent voltage drop calculation. In the second step, measuring the distance accurately is equally important. Use a measuring tape or a laser distance meter to determine the precise length of the wire run. Avoid estimating the distance, as even small inaccuracies can accumulate and affect the final voltage drop result. Consider the actual path the wire will take, accounting for any bends or turns. If the wire runs through conduit, measure the length of the conduit to obtain the wire length. For longer runs, it may be helpful to break the measurement into smaller segments and then add them up. The third step involves determining the resistance of the wire. This requires consulting wire resistance tables or using an online calculator specific to aluminum wire. These resources provide resistance values in ohms per unit length, typically ohms per meter or ohms per foot, at specific temperatures. Since the resistance of wire varies with temperature, it is important to consider the operating temperature of the wire. Higher temperatures result in higher resistance. Number 4 aluminum wire has a specific resistance value that can be found in these tables. Ensure you are using the correct table for aluminum wire and not copper wire, as their resistance values differ significantly. If using an online calculator, input the wire gauge material and temperature to obtain the resistance value. Once you have determined the current, distance, and resistance, substitute these values into the voltage drop formula. Voltage drop equals current times distance times resistance divided by 1000. Ensure all units are consistent. Current should be in amps, distance in meters, and resistance in ohms per meter. The division by 1000 is used to adjust the units and provide the voltage drop in volts. In the example provided, the current is 31.25 amps, the distance is 50 meters, and the resistance is 0.15 ohms per meter. Plugging these values into the formula yields a voltage drop of 11.63 volts. This means that the voltage at the load will be 480 volts minus 11.63 volts, which equals 468.37 volts. It is essential to compare this calculated voltage drop with the allowable voltage drop specified by electrical codes and standards. The National Electrical Code, or NEC, typically recommends a maximum voltage drop of 5% for branch circuits and feeders. For a 480 volt system, a 5% voltage drop would be 24 volts. In the example, the calculated voltage drop of 11.63 volts is well within this limit. If the calculated voltage drop exceeds the allowable limit, several options can be considered to reduce it. Firstly, increase the wire size. Larger wires have lower resistance, which reduces the voltage drop. For example, using number 2 aluminum wire instead of number 4 aluminum wire would lower the resistance and the voltage drop. Secondly, shorten the wire run. Reducing the distance between the power source and the load directly reduces the voltage drop. This may involve relocating the power source or the load to minimize the wire length. Thirdly, reduce the current. Lowering the power consumption of the load reduces the current flowing through the wire, which in turn reduces the voltage drop. This may involve using more energy-efficient equipment or reducing the load demand. In addition to these measures, it is important to ensure that all connections are properly made and tightened. Loose or corroded connections can increase resistance and contribute to voltage drop. Regularly inspect and maintain electrical connections to prevent excessive voltage drop. Furthermore, consider the impact of voltage drop on the performance of the load. Excessive voltage drop can cause equipment to operate inefficiently or even fail. Motors may run hotter and have reduced torque. Lighting may be dimmer, and electronic equipment may malfunction. It is therefore important to design electrical systems with adequate voltage drop to ensure proper operation of all connected loads. When calculating voltage drop for three-phase systems, the formula is slightly different. The voltage drop formula for three-phase systems is voltage drop equals the square root of 3, which is approximately 1.732 times current times distance times resistance divided by 1000. The steps for calculating voltage drop for three-phase systems are similar to those for single-phase systems. Firstly, determine the current. Calculate the current flowing through the wire using the formula current equals power divided by the square root of 3 times voltage times the power factor, where power, measured in watts, is the total power consumed by the load, voltage is the voltage of the system, and the power factor is a measure of how effectively the electrical power is being used. Secondly, determine the distance. Measure the length of the wire run from the power source to the load in meters. Thirdly, determine the resistance. Find the resistance of the wire based on its material, size, and temperature. Refer to wire resistance tables or use an online calculator to determine the resistance. Fourthly, plug in the values. Substitute the values of current, distance, and resistance into the voltage drop formula. Voltage drop equals the square root of 3 times current times distance times resistance divided by 1000. Another important consideration is the type of load being supplied. Different types of loads have different voltage drop requirements. For example, motors typically require a lower voltage drop than lighting. This is because motors are more sensitive to voltage variations and can be damaged by excessive voltage drop. Lighting, on the other hand, can tolerate a slightly higher voltage drop without significant performance degradation. Consult the manufacturer's specifications for the specific voltage drop requirements of the equipment being supplied. In some cases, it may be necessary to install a voltage regulator to maintain a stable voltage supply to sensitive equipment. Voltage regulators automatically adjust the voltage to compensate for voltage variations, ensuring that the equipment receives the correct voltage at all times. This is particularly important in areas with fluctuating voltage levels or where there are long wire runs. Another factor to consider is the grounding system. A properly grounded electrical system helps to minimize voltage drop and improve safety. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. Ensure that the grounding system is installed and maintained according to the National Electrical Code (NEC) and other applicable standards. In addition to the voltage drop calculation, it is also important to consider the voltage drop under different loading conditions. The voltage drop will be higher when the load is at its maximum demand and lower when the load is at its minimum demand. Perform voltage drop calculations for both the maximum and minimum loading conditions to ensure that the voltage drop remains within acceptable limits under all operating conditions. This may involve using load management techniques to reduce the peak demand and minimize voltage drop. Furthermore, consider the impact of future load growth and the voltage drop. As the load increases, the current flowing through the wire will also increase, which will result in a higher voltage drop. Plan for future load growth by selecting wire sizes that are large enough to accommodate the anticipated increase in load. This will help to prevent excessive voltage drop and ensure the long-term reliability of the electrical system. In conclusion, calculating voltage drop is an essential part of electrical system design. By following the steps outlined in this video and considering the various factors that affect voltage drop, you can ensure that your electrical system operates safely and efficiently. Remember to consult the National Electrical Code (NEC) and other applicable standards for specific requirements and recommendations.